Hello everyone. Am I audible? Just tell in the chat if I'm audible. We'll start today's session. Hope you can see the question paper. See, this is a 100 marks paper and you have 3 hours to complete this. And there are lots and lots of topics. We will see some of the important topics also which are easier so that with less time for preparing, you will be able to answer most of the questions possible. Okay. How many of you are from BIT Study Center? Just mention in the chat if you are from BIT Study Center in Bangalore, IGNOU Study Center. If you are from BIT IGNOU Study Center from Bangalore, then most of the topics I have explained in the class. This truth table, sets, relations, and functions are all explained in the class, so you will be able to solve them. Already in this question paper, you will be able to solve at least for 20-25 marks. Okay, Karthik is from BIT, right? I hope you have already gone through some of the videos like probability, and then you have permutation, combination. These things I have already told. Bhavna also from BIT Study Center. Great. I hope you have already gone through it. See here, discrete mathematics, there is a playlist which has 4 videos, which has permutation, circular permutation, combination, and then probability. That is already there. And then here there is another playlist with graph theory video. Please go through these 5 videos. Most of the permutation, combination, and probability questions are solved in this. Okay. Right. So we will discuss those things that we have not done in the class, not covered in the class. Recurrence relations are there. And it's very, very simple question. You have to identify what is order and degree of the given recurrence relations. Okay, we will see how to solve it. You will always get this question. It will be given for 3 marks, 3 or 4 marks. Yes, we didn't get enough time to complete. Kindly teach important topics for tomorrow exam. Okay. Thing is, there are lots of important topics. I'll try to cover as much as possible in this 2 hours. Literally everything is important. So whatever is possible, I'll cover. Permutation, combination, and probability, I'm not going to explain because I have very clearly explained with a lot of examples. I have explained in those videos. Please go through that. So we will see whatever is not done in those videos. Okay. See, this is one common question that has occurred in every question paper. Find order and degree of following recurrence relations. These are recurrence relations. Okay. So a recurrence relation means if you express just like recursive function in your programming, if you are expressing a particular mathematical expression in terms of itself, but for smaller input value, okay, but for smaller input value, then that is called as a recurrence relation. Say for example, n factorial can be written as n into n minus 1 factorial, right? N factorial is n into n minus 1 factorial. This is recursive definition of factorial function. Same thing if you write it in max. N factorial is written as an. It is equal to n into an minus 1. What is an? It is the factorial of n. To find out any nth term, you need to multiply its previous term with n. This is the recursive definition of factorial function. So this is a mathematical expression, mathematical way of expressing this recursive function. Hope this is clear. Fibonacci series, you know. Here, uh, and for all these recursive definitions, there has to be an initial condition. In this case, 0 factorial is 1. That is the initial condition. So when you write it in recursive definition, you will write it as a naught equals to 1. Next is Fibonacci series. I think you know what is Fibonacci series. Sum of previous two terms will give you the next term, right? So first two terms are 0 and 1. All the preceding terms are sum of the previous two terms. 0 plus 1 is 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 3, 13. So it goes on. So this is your Fibonacci series. Here, you need two initial values because every value it is dependent on two of its previous values. So to write Fibonacci series here, Fn, An, Bn, anything you can write. So if you are writing it as An itself, any nth term, if you want to find out, you need to add. See, to find out this term, you need to add this one and this one, right? An minus 1 plus An minus 2. Two of its immediate preceding terms, if you add, you will get the nth term. Okay. And first term is 0. Second term is 1. And here, n should always be greater than or equal to 3. Because suppose you take n as 2. An minus 1 is 2 minus 1, which is 1, plus a2 minus 2 is a naught. So there is no a naught in recurrence relation. It always starts from a1. a1 means first term, a2 is second term. So n should be greater than or equal to 3. That is, first and second terms are these. Third term onwards, this definition is applicable. Sum of previous two terms. Understood what is a recurrence relation? Now this is a recurrence relation. And this is the initial value. And this is also recurrence relation, and these are the initial conditions. Is everybody clear with the meaning of recurrence relation? So no, mention in the chat. First, we will see some of the. So for recurrence relation, any relation that is expressed in terms of itself, but for smaller input value, that is recurrence relation. And always an initial condition is given. Example is an equals to n into an minus 1 with a1 equals to 1. That is 1 factorial is 1. For all the other factorials, it is n into the previous factorial. This is one example. This is nothing but the factorial. Then an equals to an minus 1 plus an minus 2 with a1 as 0 and a2 as 1. This is Fibonacci series. Suppose you want to find out sum of n natural numbers, then an is n plus an minus 1. Okay, this is sum of natural numbers. Here also a1 is 1. So these are different examples. This is factorial. And then this is Fibonacci series. Is there any background noise or is it fine? And this is sum of first 10 natural numbers. Okay, these are the examples. Anyway, you don't have to know. You just have to understand what it means. Okay. Umesh from Noida Regional Center. Yeah. My pleasure, Umesh. Thank you. Fine. So this is examples of recurrence relation. Now the question for you will be, what is the order and degree of recurrence relation? First, you need to understand what they are. Order of recurrence relation means if an is dependent on, if an is dependent on an minus 1, an minus 2, up to an minus k, then k is the order. Okay, k is the order of the recurrence relation. Means you have this n minus 1, n minus 2 and all that, right? Which is the highest number like this. That is your order. Many students get confused here. They think number of preceding terms. It is actually not number of preceding terms. Sometimes one of the term might not be there. You have to see among this n minus 1, n minus 2, n minus 3 and all that, whichever is this highest number that you have, that is a recurrence relation. That is a order, sorry. That is the order of the recurrence relation. And then we have degree. Degree of the recurrence relation is highest power. Okay, highest power of an. Highest power of an. For this highest power of an, you need to have product of two ans. It can be an minus 1 into an minus 2. If you have an plus into an minus 1 into an minus 2, here there is no explicit power. But here highest power is 2 because you have product, right? And product is of both ans only. Suppose you have 2n into an. This is also product, but this is not considered for degree. Okay, degree means ans only you should multiply. Suppose if you multiply one more, an minus 3, then the degree is 3 because you have product of 3 ans. Is this clear, everybody? Now we will see the answer of the question. Here, find the order and degree of the following. So for the first one, what is the order? See which is highest here. N minus 2 is there. So 2 is the highest one. So order is 2. See, you can have like this also. An is equal to 2an minus 2 plus 3n. Something like this. Here, n minus 1 is not there only. It is okay. So what you have, highest number here is 2. So that is the order. Okay. And then degree. Degree is, you see that there is no product. Therefore, you just see the highest power. Highest power is 1. Therefore, degree is 1. Here, what is the order? Order here, again, n minus 2 is there. Therefore, 2 is the order. And for degree, ignore the root part. Here, a n minus 2 has square, right? So, degree is also 2. Understood this? They have not asked you to solve it. You have to just write order and degree. That's it. No calculation, nothing. Let me know if you have understood or not. I will take MCS 33 question paper also. Please respond. And then you have homogeneous and non-homogeneous recurrence relations also. Let me take this. I don't think you will get questions of this type, but still here they have asked you to find order and degree. Here also you will have to find order. They've not asked us to find degree. We will write that also. Anyways, there is no power and there is no product. Therefore, degree is 1. And here, uh, homogeneous and non-homogeneous is given, right? So what is homogeneous and non-homogeneous recurrence relations means? In homogeneous recurrence relations, only an terms will be there, nothing else. An, xn, whatever. In non-homogeneous recurrence relation, you will have other terms also. Other terms also it will be there. So what are these other terms? Can be just a constant, can be some term with n like this. It can be something like this. Okay. So along with this an terms, so when I say an, it can be an minus 1, an minus 2. All these are considered as an only. Non-homogeneous recurrence relations means you will have either a constant or a term with n like this. Okay. This will be non-homogeneous recurrence relation. Now for the first one, it is not n minus 1, right? It is n plus 1 and all that. So always write it as in the second form. That is an minus 1, an minus 2. That is how it has to be. It should not have n plus 1, n plus 2. If it is that, change it. So first one is xn plus 1 plus 10xn plus 22x n minus 1 equals to 4. So wherever n is there, see, highest number I want is n only. Highest subscript should be n. Okay. So here what is the highest subscript? N plus 1 is there. So I need to subtract 1 for all the subscripts. Subtract 1 from the subscripts. So here n plus 1 minus 1 is n plus 10, xn minus 1, xn minus 1 plus 22. Here already xn minus 1 is there. Another minus 1 if you do, it will be xn minus 2. Here you minus 1, here also you minus 1. Wherever that n is there, everywhere you do minus 1. Okay. So this becomes xn, this becomes xn minus 1, this becomes xn minus 2. And suppose you had n here, here also you should do minus 1. Okay. But here we don't have. It's just a constant. So write down the constant. Now tell me what is the order. Tell me the order and degree. Yashwant. No, Yashwant, right now we are not doing it. That was a service we provided long back. Now I do not have my those assistants, interns. I have interns working for me, and those interns were the ones who used to do that according to my instructions. Okay. Now we are not doing it. Okay. So n equals to n minus 1 place n minus 2 up to a naught. Santosh says order is 1. Correct. Order is not 1. Sorry. Order is 2. N minus 2 is there, no highest. So order is 2. Degree is 1. Is it clear, everybody? See here, there is no calculations involved. Okay. It's only identification of order, degree and all that. So don't make mistakes in this. Is everybody clear with this? Order 2 and degree 1. Order is 2 because n minus 2 is there. If n minus 3 is there, order will be 3. If only up to n minus 1 is there, order is 1. Understood? See, for this one, order is 1 because only up to n minus 1. Here I have n minus 2, so order is 2. Here only n minus 1, so order is 1. It means last one, yeah, not necessarily last one, this highest number. Usually that will be the last. Degree is a power. Whenever you are writing degree, just observe whether you have products. Here there are no products. Each term has one xn only. Ma'am, does -4 come on LHS and becomes non-homogeneous? See, whether it is in the LHS or RHS, it is non-homogeneous only. Okay, this is non-homogeneous because you have a term other than this xn. Here, see, this term has xn, this has xn, this has xn. This is the only term which does not have xn, right? At least one term if you have which does not have this xn, an, whatever, that is non-homogeneous. Here, this relation is non-homogeneous. Okay. The next one. What is the order? Here, there is no need of any degrees power of variables. It is a power of an or xn. See, suppose you have 4n square here. You cannot take degree as 2. Okay. Degree is only for this xn or an term. It is a power, but not for such constants, for non-homogeneous terms. It is of this xn or an, whatever the recurring term you have. For that, what is the power? That is degree. But sometimes you will have like this, an minus 1 into an minus 2 plus an minus 3 into an minus 4. In this case, there is one term multiplied with another term, right? So degree will be 2. Okay, Nisha says is the first one non-homogeneous recurrence. Yes, this is non-homogeneous. Okay, this is non-homogeneous. And this one is not non-homogeneous. See, this first example I have written here for factorial. This is not non-homogeneous because right hand side there is only one term. It is also multiplied with n. That's it. N into an minus 1. There is only one term. Okay. So this is also homogeneous. If you have one more, suppose n into or whatever, plus another term like this or 5n, 5n square, whatever, then it is non-homogeneous. So this first one is non-homogeneous because it has 4. Understood, Nisha? Now order. So here, whenever a recurrence relation is dependent on all its preceding terms, order is not defined. Okay, order is not defined. Why? From n minus 1, n minus 2 up to a naught is there. Therefore, order is not defined. Make a note of this. Degree here, there is no product and there is no power also given explicitly. So degree is 1. Whether this is homogeneous or non-homogeneous? Tell me whether this is homogeneous or non-homogeneous. I want you people to answer. Suman says homogeneous. Yes, correct. It is homogeneous because you don't have constant or the additional terms and all is not there. Therefore, it is homogeneous. Right. Just identification, that's it. Solving recurrence relations is there, but I think that will take a lot of time. So we will not see the solving of recurrence relations. This is a simple question which repeats sometimes. So it's easy for you to, yeah. So this is homogeneous, correct. Shweta, Hina, correct. This is homogeneous. Okay, now let us see the next question. See here this question. Show that root 5 is irrational. Show that root 5 is irrational using proof by contradiction. So this question I have explained in the class. If you have attended If you are a student of BIT, you will know I have explained in the class. And exact solution is present in study material. Please go through that. It is easy to understand. Truth table. Does everybody know how to write truth table for 5 marks? It will be given. It's very simple. Yes or no? Yes. I think there is a lag. Truth table. Do you know? Do you want me to explain? If you know, I'll go to the next one. No response. I believe you know it. Please do one problem on solving recurrences. It will take time, and I'm just trying to focus on easy questions so that everybody will be able to. Okay, truth table. You know, I don't know what is your S. Is it for? Do you want me to show an example, or do you know? We know. Okay, fine. Thank you. Hmm. I think Boolean expression, you know how to write. And also if expression is given, how to write the circuit, that you will definitely get a question on that. A 3 or 4 mark question. See, if you have to write expression based on circuit diagram, 3 marks will be given. If expression is given and if you have to write the diagram, they will give you 4 or 5 marks. Okay. I believe you know this. Quite simple. Go through the study material examples. You will understand. This is and gate is this. And for this you write, this is a symbol for and. OR gate is this one. For this symbol is this. And NOT gate is, this is NOT gate. For this, the symbol is this one. Suppose you have NAND, then you can write like this. For this, you write and for that, you write the whole bar, whole dash. So, see what are the inputs? A and B are passed as input for AND gate. AND gate means this one, right? So, it is A and B. And then this is the output. This output is A and B. For this output, see here, A and B are taken for AND gate. This is AND gate. So output of this is A and B. And then it is passed through a NOT gate. So A and B whole dash. Don't write individual dash, it is whole dash. Okay. And then here we have an input C and that is passed through NOT gate. So this is C dash. Both these are passed through AND gate. Therefore, first input is this one, A and B whole dash, and then and this one, C dash. Okay. So it is recommended that you write this circuit and write these outputs at every arrow. That will make sure that you are getting full marks instead of writing one final expression. If you write this way, it shows that you are very clear with what is the output of each and every gate. Okay. So final Boolean expression is A and B whole dash and C dash. Right? So this is how you write Boolean expression. In the same way, you will have to write the diagram, circuit diagram also. Let me see if there is any expression given for which you are supposed to write the diagram. So here, see, they have given 8 marks for drawing a diagram. Given Boolean expression A naught. How to find bipartite graph? There is no finding bipartite graph. Anyway, we'll see. So A dash or B and C dash and B or D dash. Okay. Draw the corresponding circuit where A, B, C, and D are inputs to the circuitry. Right. So here this is OR. For that there is AND. So whatever is the innermost bracket, you have to solve that first. So B and C is there. So B is one input and C is other input. These two inputs go to the AND gate, right? AND gate. And C is dash, C dash. So C, you have to pass it through an NOT gate. Okay, so this is B, this is C dash. B and C dash, this is the output, B and C dash. Now with this input, this goes as input for an OR gate for which A dash also is there. So you write an OR gate. This is B and C dash, and then you have A that passes through a NOT gate. This is your this output. And B or D dash. So here this one input and then it goes as a input for another AND gate. This is one input, which is this one. With this we have B or D dash. So take D and pass it through a NOT gate, and we have to take another OR gate here. For this the inputs are B and D dash. So D dash is this input and B. So write a line from B, and this is B or D dash, and this input also goes to this one. Okay. This is your circuit. Is this clear? This is your output. This carries 8 marks. Just make sure here also everywhere you just write whatever is output obtained. This is A. After passing through NOT gate, you will get A dash. This is B and this is C dash. So this is B and C dash. So this is going to be A dash or B and C dash. And this is D dash. So this output is B or D dash. This is a final output. So this carries 8 marks, quite an easy question. So Boolean expressions, you will definitely have one question. Either they'll give you circuit and ask you to write expression. In that case, it's going to be just a 3-mark question. Sometimes they'll give you expression and ask you to write the circuit. In that case, you will get at least 5 marks. 5, 6 or 7 marks you can get. 8 marks is very rare actually, but if you get 8 marks, it's good. December 2021 question 3C. 3C, this one. This f of x whole square, is this what you're asking? This comes under functions. December 2022. This one, does everybody know? This is functions. Here f of x is x squared, g of x is x plus 1. Find f of gx and g of fx. For this, first find out to find f of gx. It is same as f of g of x. First apply g of x. G of x is x plus 1. F of In place of g of x, you write this x plus 1. Now, you have to apply f definition. What is f definition? Whatever is there in the bracket, you are squaring it. So whatever is there here in the bracket, you are squaring it. That's all. This is f of gx. Okay. Regular expression. Yes, we will do it. Next is g of x. G of f of x. Okay. G of f of x. So g of f of x definition you write, which is x square. Now apply G definition. What is G definition? Whatever is there in the bracket, you are writing it and then adding 1. So write what is there in the bracket, which is x square. To this you add 1. Okay, that's all. No other simplification. Sometimes they'll give you find out f of g of 1, f of g of 2, whatever. So in such cases, don't substitute that 1 or 2 here itself. You shouldn't do that. First, find out what is f of gx. After you find this, then you find f of g of 2 is equal to, in this you substitute 2. You get 2 plus 1 whole square, which is 3 square, 9. Okay, this is functions. You know how to solve this permutation probability based questions? Graphs, I think this I have already explained. There are different types of graphs. There are different types of graphs. You have Euler graph, Hamiltonian, bipartite graph, complete graph, connected graph, all these things. Just go through that graph video also. There also I have explained some of the questions from previous year's papers. Digraph is a digraph is a short form of directed graph. A graph which has directions. Write the definition from the study material. You have to write a graph G is a set of v comma e. It's a relation between v comma e where v is a set of vertices and e is a set of edges which are formed between vertices. There is a formal definition. Write that. And then for all the graph problems, even if they have not given that an example is required, you must give an example to get full marks. Okay, this is an instruction for all graph related questions. Even if in the question, if they say, if they do not ask you for an example, you have to write an example. Next, complete graph of 3 vertices. So 3 vertices. Complete graph is one in which every vertex is connected with every other vertex. So A, B, C. A is connected with B and C. B is connected with C and A. C is connected with A and B. This is a complete graph with 3 vertices. Suppose it is 4 vertices. A, B, C, D. A should be connected with all the other vertices. B is connected with all the vertices and C, D, everything is connected with all other vertices. This is complete graph. They have given complete graph of three vertices. This is what you need to write. Here, make sure you write some details. N is 3. Vertex set is A, B, C. Okay. Edge set is, what all edges you have here? A, B, B, C, A, C or C A. Anything you can write. Since there are no directions, you can write anything. Degree of a vertex is a number of adjacent vertices it has. So to how many other vertices it is connected, that is degree of a vertex. Here A is connected with B and C, therefore its degree is 2. B is connected with C and A, therefore its degree is also 2. C is connected with A and B, therefore its degree also 2. Count to how many other vertices it is connected. That is degree of a vertex. Take some random diagram like this. Okay, just write something like this. This is A, B, C, D, E. Write what is degree of a vertex. It is number of adjacent vertices a given vertex has. That is the degree of the vertex. And then write a graph like this. In the given graph, degree of A is 2, degree of B is 2, degree of C is 1, degree of D is 2, degree of E is 3. So like that, you just write a graph and as an example and explain. Next, regular graph means all vertices have same degree. All vertices have equal degree. Okay, all vertices have equal degree. That is regular graph. Just a second. So in a graph, if all the vertices has same number of degree, then that is a regular graph. So if you write like this is a regular graph, but not a complete graph. Here, all vertices have degree 2. Okay, this is a regular graph. These are the examples of graph. Then what have you given? How to find bipartite graph. See, there is no finding bipartite graph, but I'll tell you what is an example of bipartite graph. Maybe they might ask you an example. Okay. If a graph is given and if they ask you to find whether it is a bipartite graph, then you have to divide the vertex set into two set of vertices such that they are disjoint sets. I'll just give you an example. So bipartite, partite means partitions, bi is 2. If a vertex set is divided into two subvertex sets, vertex set V is divided into two subvertex sets. Okay, two subsets V1 and V2. And this V1 and V2 are disjoint sets, means whatever vertices are there in V1, we will not write it in V2 also. So whatever vertices are there, you're going to divide them into two groups. And vertices from vertices of V1 are connected with vertices of V2, are connected with vertices of V2. Vertices among V1, there will be no edges between them, and vertices among V2 does not have edges between them. So it is like match the following. Okay. So from this vertex and this vertex, from the first set and from the second set, vertices are connected. That is bipartite graph. I'll give you an example. I will take vertex set V with 5 vertices A, B, C, D, E. Okay. And I will divide them into this. A, B, and D are one vertex set. C and E are another vertex set. Again, this is just an example. Here, V1 is A, B, D. V2 is C and E. Now, edges are formed from this set to this set. A to E, B to C, B to E, D to C. So, this is a bipartite graph. Okay. A vertex is divided into two partitions. Is this clear? Example of a bipartite graph. Now in this we have complete bipartite graph. What is complete bipartite graph is? Each and every vertex of first vertex set is connected with all the vertices of the second set. That is bipartite graph. Here see, A is connected with E. A is not connected with C. So connect that also. B is connected with both C and E. D is connected only with C, connected with E also. So now this is a complete bipartite graph. Each and every vertex from the first set is connected with all the vertices of the second set. See, among A, B, A, D, there should not be edges. And between C and D, there should not be edges. This is one set, this is one set. Within the vertices within a set will not have edges between them. This vertex to this vertex, there will be edges between them. Understood this? So if V1 has M vertices and V2 has N vertices, okay? If V1 has M vertices and V2 has N vertices, then complete bipartite graph will have M into N edges. Complete bipartite graph will have m into n edges. Three vertices are there here. Here you have two vertices. So 3 into 2, 6. That is the maximum number of vertices a bipartite graph can have. And if a graph has the maximum number of vertices possible, then it is called as a complete graph. So this is complete bipartite graph. If one or two edges are missing, then it is just a bipartite graph. Understood difference between a bipartite graph and a normal graph? So when a graph is given and if they ask you to find whether it is a bipartite graph or not, then you just write them into two groups. The vertices, you write it into two groups. I'll take one example. Something like this if they give you and ask you to find out. F, G. Suppose they give you a graph like this and ask you to find whether it is a bipartite graph or not. Then this is a rule for bipartite graph. There is one main vertex set and you will have two subsets V1 and V2. Among the edges of V1, there won't be, among the vertices of V1, there won't be any edges. Within vertices of V2, there won't be any edges. Okay. For this, vertex set now has 6 vertices, A, B, C, D, E, F, G. 7 vertices are there. We will divide it into V1 and V2. Now A to D, there is an edge, right? So I will write A here. Which all vertices A is connected with, all these you put it in vertex V2. A is connected with D and E. So write that here. Okay. Now, next vertex is B. B is connected with D and F. Since D is in this set, B should not be in the same set, right? So B, you write it here. Now B is connected with D and F. D is already written here, so write F. Next is C. Now C is connected with E. Since E is in this vertex, you write C in the opposite vertex. C is connected with E as well as G. So E is here, G you write here. Okay. Have you written all? Yes. Now see, among A, B and C, there are no vertices. There are no edges connecting them. Among D, E, F, G, there are no edges connecting. Okay. Therefore, this is a bipartite graph. Suppose you had like this. Suppose you had like this. Then what happens? Now, this is not a bipartite graph. We'll see how to write. So take a vertex, any vertex, you take A, to which all vertices it is connected, write it in the opposite set. A is connected with D and E, so I will write it in the opposite set. Now, this set, now take a vertex from this set, whatever you have already written. I have written D. Now D is connected with B, right? So this, the vertex is connected with D, you should write it in the opposite set. Now for B, what all connections are there? You see, B is connected with D and F. D is already there here, so F is written. Next, A and B done. Now for D, whatever connections are there, we have already written. Now I'll take E. E is connected with A, C, F. All these three are supposed to come in the opposite set where E is not there. Okay. So here, E is connected with A, C, and F. So you're supposed to write A, C, F all here in the opposite set. A is written here. So you're supposed to write C and F. But F is already there in this set, right? So F is there here. And E is connected with E is connected with F and E and F are present in the same set. Therefore, it is not a bipartite graph. Okay. So you can write here, then C is connected with G also. Since F is present in both the sets, it's not a bipartite graph. Is it clear? only for complete bipartite. No, no. See, this is not complete. Complete is where every vertex is connected with every other vertex. I think you're asking about this. This is only for complete bipartite. If a graph is given and if they ask you to check whether it is a bipartite graph or not, this is how you need to do. First, take any vertex, write it in one set. To which all vertices it is connected, write all those vertices in the other set. Now, in this set, you take one vertex, to which all vertices that is connected, write it in the opposite set. This way, you finish writing all the vertices. And then you see that if they do not have any common vertex, then it is a bipartite graph. Previously, this E to F was not there, so it was a bipartite graph. Now, because of this E to F, you see that F has come here also, here also. Therefore, this is not a bipartite graph. Hope it is clear. Okay. Next you have okay, one of the student had sent me a message. Is that student here? I'm not sure. Sorry, I'm not well, so I'm missing every now and then. Is this student there? Suraksha? Suraksha is there in the session. Suraksha had given a question. He had asked in the set of all natural numbers whose squares is more than 26. What is a complete? I think this is what you are asking about, right? Write mathematical notation for the following. You're supposed to write mathematical notation. This is set theory. You have to write mathematical notation. Set of all odd numbers. Okay, we will take it as set A. All numbers 2x plus 1 and x can be greater than or equal to 0. 0, 1, 2 goes on. If it's an even number, you can express it as 2x. If it's an odd number, you can write it as 2x plus 1. Now, this is set of all odd numbers. They have not given positive or negative, right? So you can write 0 plus or minus 1, or you can write x belonging to z. Z means a set of integers which include 0, plus or minus 1, plus or minus 2, everything. Okay. So when x is 0, 2 into 0 is 0, plus 1 is 1. When x is 1, 2 into 1 is 2, plus 1 is 3. So you will be getting 1, 3, 5, 4, 5, 7, 9. And if you take negative numbers, then you will get negative odd numbers. Okay. So this is the mathematical notation for set of all odd numbers. Next, set of all natural numbers whose square is more than 26. So this I will take it as set B. This includes all natural numbers x such that it belongs to set of natural numbers such that x square is greater than 26. This is the mathematical notation. One example of truth table. Okay. Understood mathematical notation? Set of all natural numbers. So you should write x that belongs to natural numbers. And what is the condition? Its square should be more than 26. So x square should be more than 26. This is how you write mathematically. 2 marks for each of this. No need of explanation. You are just supposed to write the notation. truth table. See, for many questions, the procedure will be same to write x greater than 5. Can we write like this? Yes, you can write. You can also write x greater than 5. Correct. Because when x is equal to 5, the square is 25. For the numbers less than 5, the square will be less than that, less than 25. So numbers for which the square is greater than 26 is x greater than 5. It is correct. But we will try to keep this definition intact. Okay. It depends on the evaluator then. X greater than 5 will give you the same set of values. But when it is given whose square is more than 26, let us keep the notation in the same way. Okay, so assuming that P and Q are two propositions, find if the following two statements are logically equivalent or not. See, for all these things, if you are constructing truth table, then procedure for constructing truth table is same. If they ask you to find whether two statements are logically equivalent, then these two columns should have same set of truth tables. Sometimes they will ask you to find whether a given statement, logical expression is a tautology or a contradiction. Tautology means all the values, truth values in that column should be true. Contradiction is where the entire column values will be false, the final column. In that case, it is a contradiction. Okay. So for all these things, you will be basically writing truth table. Procedure for writing truth table will be same in all these problems. How many inputs we have here? P and Q, only two inputs. So let us write P, Q. Since there are only two inputs, we will have to write 4 lines. See, N is number of inputs. Okay. And 2 power N should be the number of lines, number of combinations you write. This I have explained in my if P then Q. This I have explained in the regular class in detail. So here I have two inputs, only P and Q are there here. So 2 power 2 is 4. So you should write 4 lines here. Suppose you have 3 inputs P, Q, R, then 2 power 3, 8 you should write. Okay, means here I should write only 4. So I am going to write like this, 2 T's, 2 F's. Here we will write TF, TF. Okay, suppose you had R also. Okay, if you have R also, then you should be writing 8 inputs, right? For the first line, divide this into 2, 4 and 4. So 4T, 4F. And then here alternate with 2T, 2F. 2T, 2F, again 2T, 2F. Now for the last one, alternate TF, TF. TF, TF. Okay, this has to be written. This is your input combination. If you have 3 inputs, 8 lines you should write. This is the order in which you should write. If it is only 2 inputs P and Q, then only 4 are required. And I told you how to write. 2T, 2F in the first line, TF, TF in the second column. T, T, F, F, TF, TF. Now write what all is required. First we need P or Q and then we need to negate it. We need not Q and not P is not required. So I will write not Q, or first I'll write this. First I'll write P. Order in which you write doesn't matter. Okay, first I'll write P or Q, then I will negate it. Not P or Q. After that I will write not Q. Then I will add these two. I mean, I have to apply disjunction between this. Not P or Q or not Q. Okay, this is your LHS. I've named it as column number 1. Next we have P or not Q. With this, I have to again apply or Q. P or not Q or Q. So this is my second column. That is this second expression. Okay. Now after writing the truth tables, I will have to compare this column and this column. If these two expressions are logically equivalent, then this column and this column will have same truth values. Now let us write this P or Q. What is OR? If at least one of the input is true, output will be true. Or in other words, if both the inputs are false, output will be false. See, both inputs are false, therefore output is false. In all other cases, output is true. This is OR. Okay. Next is not of this. Means you have to just reverse the truth value. Not of this. So you will get false, 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 true. Next is not Q. Q is here, which is TF. Not Q will be the opposite. That is FT. Now I have to take this one or this one. So among these two, if both are false, output will be false. Otherwise, even if one of them is true, output will be true. See here, both are false. Here only one of them is false, so it is true. Here both are false, so output is false. Here both are true, so output is true. Done. This is one of the expression. This one is done. Now we have to do for this P or not Q. P or not Q is we have to take P and then we have to take not Q. Okay, this first column and this column. If both are false, the output will be false. Otherwise, it will be true. Here, true and false is true. True and true is true. False and false. And then false and true. This is true. Now we have to, with this, have to apply OR Q. Q is the second column. So with this previous column, I'm going to take this column and write T and T is T. And then T and T is T. F and T is T. T and F is T. F and T is C, or it is, right? So even if at least one input is true, output is true. These three are true. Therefore, this three will be true. Here false is there. Just take its other output. So this is true. Therefore, all are true. This final expression is a tautology. Okay. So this is a tautology because all the values are true. All truth values are true. So comparing column number 1 and 2, they are not identical. You have to compare this two. This and this should be same. In the same order. If it is same, we say that they are logically equivalent. Otherwise, we say that they are not logically equivalent. We say that column numbered 1 and 2 representing given two equations, given two expressions represents given logical expressions. Okay. And we see that they're not identical. They are not identical or truth values are not identical. Therefore, they are not logically equivalent. Okay. Therefore, they are not logically equivalent. Hope this is clear. This is writing a truth table. Can you explain if P then Q? See, for if P then Q, first one should be true. Okay. And then second one should be false. Then the answer is false. In all other cases, answer is true. Understood? If first one is true, second one is false. First input is true, second input is false, output is false. In all other cases, output is true. So if you have P and Q, you have four inputs, right? TT, FF. Here you have TF. If P then Q means if first one is true, second one is false, output is false. In all other cases, output is true. Okay. If first input is false, output will be true, irrespective of what you have as a second input. This will save time. Okay, these techniques will save time. So if P then Q, it is false only when first one is true and second one is false. So if first one is false, whether second one is true or false, output will be true only. So I'm writing it directly. Only if first one is true, I'll check what is second one. If second one is false, output is false. Otherwise, it is true. Okay, this is if P then Q. Hope Santosh, you have understood. Towers of Hanoi problem is important. So just go through that. See here, there is a question for 6 marks. Find degree and order. Define degree and order also. So you just see what is a formal definition of degree and order. I have already told you what it is. Degree is the highest power of an. Order is the an minus 1, an minus 2 up to an minus k if it depends on that k is a order. Okay, fine. Okay, Vaibhav. So here see 6 marks. For definition of degree and order, 1 mark each. This one 1 mark, this one 1 mark. And for these two, again, 2 marks, 4. Yeah. For degree, 1 mark, order 1 mark for each of this. Write the formal definition of this. Here, order is highest is 4. Therefore, order is 4. Very simple. What is the degree for this first one? Here again, order is 2 because highest number here is 2. Therefore, order is 2. What is the degree for this first question? Yes, anybody? Degree 3. Yes, Shweta, good. Degree is 3 because see, we have a product here. Here there is a power. Power is 2. Okay, but degree is not this. Degree means if you have product, see how many numbers are there multiplied. That is the degree. So here you have an minus 2, an minus 3, an minus 4. 3 terms are multiplied. Therefore, degree is 3. Here, degree is 1. Okay, n into an minus 2 is there, but that is not considered as a product. Product is only when you're multiplying two ans. An minus 1 into an minus 2, that is degree 2. N into an minus 2, we will not consider. Okay, so an minus 2 only is there. So here degree is 1. Hope this is clear. Where, see, no simplification, nothing. Just write a simple one-line definition for degree and order, and then you have to just find order is this, the degree is this. That's it. 6 marks, it's like quite an easy mark. Okay, I think we'll take a break. And then what is this? Degree 2 for which one? No, no, degree is 1 only. For last one, degree is 1. Pigeonhole question, yes. And then regular expression, yes. We will take a break and then we will solve that. Okay. We'll take a break of 5-6 minutes and then we'll come back and we'll continue with the remaining problems. Welcome back. Am I audible? Can you hear me? Yes. Okay. What are the questions? Pigeonhole principle. Right. Am I audible clearly? Kindly mention in the chat. Show using pigeonhole principle that in any group of 30 people, 5 people can always be found who were born on the same day of the week. This question can also be asked as in a group of 30 people, what is the minimum number of people who can be born on the same day of the week? See, all these 30 people can be born on Monday only, right? That is a maximum number. What is a minimum number? So that is obtained using this pigeonhole principle. Okay. So according to pigeonhole principle, if there are n objects, you don't have to write pigeonhole principle as an answer. You should just solve it. I am explaining what is pigeonhole principle. This is used to find minimum how many objects should be put in each of the container. Mm, Pigeonhole principle. So according to this pigeonhole principle, if there are draw two isomorphic graphs and three non-isomorphic graphs and five vertices. Okay. So if there are m containers, okay, if there are m containers and n objects, if there are m containers and there are n objects to be placed in those containers with number of objects more than number of containers. Okay. Number of objects is more than number of containers. Then the minimum number of containers that will be present, at least one container will have more than one object, right? Then at least one container will have more than one object. This is pigeonhole principle. How many objects will be there is what we are supposed to find. At least one container will have more than one object. See, if there are 5 objects and if there are 5 containers, then every object can be put in a separate container. Suppose there are 5 containers, 5 boxes, but then you have 12 objects and you have to put it in these boxes. At least in one container, you will have more than one object you have to put, right? Because number of containers are less. So this is pigeonhole principle. Using this, we usually find out what is the minimum number of repetitions that is required, or so such kind of problems is what you will solve here. So in this, to find out how many objects will be present in that one container, the number of objects or number of objects present in a container, this is minimum. Okay, minimum number of objects in a container is given by it is number of objects divided by number of containers plus 1. This is a formula. Okay. Number of objects divided by number of containers plus 1 is a formula. Now here you have to show that minimum number of objects, minimum number of people born on the same day of the week is 5. Answer they have given, you are just supposed to use this formula and write, that's it. So just write this description. Number of people is equal to 30 and then number of days of a week. So what are we finding here? How if I put this people into groups and the groups are based on day of the week in which they were born. Okay. If 2 people are born on Monday, they are made as one group. And if there are 3 people born on Tuesday, they are made as one group. So something like that. So if I group them that way, then that groups are nothing but the days, right? So number of containers here is nothing but number of days, which is 7. Because we talk about day of the week, there are 7 days. So this 30 people, I have to group them into 7 groups. Now minimum number of people born on the same day. Born on the same day is equal to, it is n divided by m. So this is n, number of objects. This is m, which is number of containers. It is n by m plus 1, which is 30 by 7 plus 1. What is 30 by 7? You will get 7 fours are 28. Then 2 is a reminder. 2s are 14. Then 6 is reminder. 9s are 54 plus 1. Okay. 7 fours are 28. Yeah. So 4.29. Actually, it is 4.28 plus 1, which is 5.28, which is approximately equal to 5. Understood? Is approximately equal to 5. So that is a number of people, minimum number of people born on a same day. Hope it is clear. This is pigeonhole principle. Then regular expression, describe each of the following languages. Isomorphic graphs, Vaibhav, I have already explained in one of the previous videos. Please go through that. Are you in the WhatsApp group, Vaibhav? If you're there, I will share the video where I have explained only previous years graph theory questions, which are quite easy to understand. All important questions I have explained. You can watch that. What are isomorphic graphs and how to prove it. Now we will go to this regular expression. Finite and okay. Regular expression is an expression that generates a language. Okay, so when it generates different words of a language. Now we will see how to write a regular expression for a given language. Also how to generate strings. Regular expression. You need to know grammar also. Anyway, I'll just say, see, if you have to have at least one letter, you should use plus. And if you have 0 or more letters, you will use star. Okay, that is called as clean star and clean plus. That is the terminology for the grammar. Then to write regular expression, where is that question? Huh. Find regular it's a general format for the values. Look at the format of these. Here we have two letters. These are called as elements of the language. Alphabet set has these letters. So sigma is an alphabet set which has A, comma B. Okay, this is alphabet set. And L is a language here. For this, instead of listing this way, we need to write one expression, a general expression that graph notes, not notes, it's a video. You go through that. There is no notes for that. And this language, you should write one expression that generates all such values. Now see, the first one is A, last one is A. Okay. First letter is A, last letter is A. So it should start and end with A. In the middle, you should have B. Number of B's can be 0 or more. See, in the first expression, there is no B only. Second expression, there is one B, and then it keeps on increasing. So it is B star. Okay. Suppose here, if this was not there, then it means you need to have at least one B, right? So in that case, you will write B and then B star. You will write A, B, and then A. One B is must. Additional any number of B's you can have. So that is if your first word itself starts from ABA. But here the first word is A. So minimum requirement is A. In between any number of B's can be there. So here it is A, B star A. That's all. Okay. This is a regular expression for this language. Understood? Okay. Consider the following finite automata. What would be the values of these things for the automata given? And what is the other question? Did you understand who asked for this regular expression? I think Jyoti Singh. Have you understood, Jyoti? Give one string that will be accepted and one string that will not be accepted by this finite automata. See, automata is a machine that is used to accept or reject strings. These are used for pattern-based searching. Okay. Automata is a logical machine. It's not a physical machine. It's a logical machine that accepts or rejects a string. Okay. String means it is a series of characters. Now, this automata is specific for each language that we design. So, automata is designed according to the language. And when we pass an input string, if it has to start from an initial state, and at the end of the string, if it is in final state, what does this in the expression mean? That is any number of times it can repeat. It should, if you write that one, that symbol that you have given, it means it repeats once. Star means it can have 0 or more number of times. Okay. Uh, Star is 0 or more. This is at least once. Instead of that, you can even write B into B star. What I was saying. So you have to start from the initial state, and at the end of the string, if you stay in the final state, it means that string is accepted by the automata. If it does not end in the final state, then it is not accepted by the finite automata. Here we have two types. One is deterministic finite automata, DFA, which is deterministic finite automata. And then you have NDFA or NFA, which is non-deterministic finite automata. Okay. So in deterministic finite automata, for every at every state, at every given state, for each and every possible input, there is a way available. and it is not ambiguous. So that is deterministic finite automata. For non-deterministic finite automata, it is just the basic automata that accepts a string. So in some of the states, there can be ambiguity, and in some of the states, there is no next path also. Even that those are the two cases under non-deterministic finite automata. So a finite automata is expressed like this. Okay, so here this is how you express a finite automata. Here each one has certain meaning. Q is it is a set of states. It is a set of states. Okay, and it cannot be empty. It's a non-empty set of states. Again, please go through the study material for formal definition. I'm giving you the meaning so that you can easily remember. Then this sigma, it is an alphabet set. Like here in the previous example, we have just A and B. For most of the problems here, we will be taking A and B only. Okay, it is alphabet set. And this is a transition function. Okay, transition function. So this is a transition function. You can also call transition table, which gives you a table. And from every state, what is a uh, next state for each and every input that will be represented in the form of a table. That is a transition function. It is written in the form of a table. And then Q naught. Q naught is something that belongs to the set Q, and it is an initial state. Okay, it is an initial state. Always we write it like this. It means this is where the automata starts. Okay, and then F is a final state. It is a final state, and this is also belonging to the set of Q. And for this F, we write double circle. It means it is a last state. Okay. From final state, it can again come back to the one of the previous states also. So this is a finite automata. Example is this diagram, whatever is there here. This type of some diagram you write. That will be the example for finite automata. Everybody understood what is finite automata? And I mean, this is finite automata, deterministic and non-deterministic, I'll tell you. Has everybody understood this? Please give me the answer. Okay, so we will take this example and understand what it means. Okay, here you can let us write all these things. That is the question here basically. Consider the following finite automata. What would be the values of Q, sigma, this rho, Q naught and F for the automata given above? So whatever we have written earlier, the for answer for this one, those things we have to identify in this one. Okay. What is Q? Q is set of all states. So here Q is set of all states. So you have Q naught and then Q1. Q2 is not there. We have Q3 and Q4. This is set of states. Is this clear? This is Q. Next is we have sigma, which is alphabet set. So see whatever is written on these arrows. These are the alphabets set. These are the alphabets, elements of the set. Okay, it is A comma B. That's it. Next, we have to write transition function. Can you tell me which is the initial state here? Since we have an arrow mark, this is the initial state. Q naught is Q naught only. Q naught belonging to Q is the initial state. And then what is the final state? Q4 has this double circle, right? So that is the final state. Now we are supposed to write this transition function. To write transition function, we will write a table. In this table, we will write all the states in the first column. Transition function row. We will write states here. These are the inputs A and B. Okay. Start from the first state. What all states we have? Q0, Q1, Q3, Q4. Write all the four here. Q0, Q1, Q3, Q4. Okay. You just have to write from Q0, if input is A, to which state it will go. And from Q0, if input is B, to which state it will go. Just you have to write that and make sure you write this. This means it is an initial state and this represents it is a final state. So wherever you write Q4, make sure you're marking it with double circle because that is a final state. Final state because it is there in the diagram like that. Now see, from Q0, if it is A, it goes to Q3. If it is B, it goes to Q1. From Q0, if it is A, it goes to Q3. If it is B, it goes to Q1. Okay, B goes to Q1, A goes to Q3. Done. Now from Q1, if it is A, it goes to Q3. A goes to Q3 and B goes to Q4. On input B, it goes to Q4 and this is a final state. Remember, so we have to write like this. Next from Q3. From Q3, see A and B both remains in same state Q3. So from Q3, whether it is A or B, it will remain in Q3 only. Next, from Q4, both A and B will remain in the same state Q4. Q4, Q4. Just write this double circle. This is a transition function. Understood how to write all these things? Now, how do you know whether it is a deterministic finite automata or non-deterministic finite automata? See, we wrote transitions from every state to every other state based on all the inputs. Here only inputs are A and B, right? Only two inputs are there. For each of the input from every state, I have written what is the next possible state. And if you have seen, when we wrote this table, we did not have any confusion. From every state, there was only one and only possible state for every input. For A, it went to Q3 only. No confusion. For B, it went to Q1 only. No confusion. So this is a deterministic finite automata. What is non-deterministic finite automata is, suppose this arrow was not there. Okay. Suppose this arrow was not there and this arrow was not there. This and this, if it was not there, then from Q0, if it is A, it will go to Q3. If it is B, it will go to Q1. And from Q1, if it is B, it will go to Q4. If it is A, where to go? It is not mentioned. So from any state, if what is the next state for a particular input is not given, it is non-deterministic finite automata. Or from any state, if there are two ways for a single input, that is from Q1. If you have multiple B's, it is in Q1 itself. Also, you have written one B to Q4 as well, right? From Q1, if it is B, it can either stay in the same state or it can go to Q4 also. So from any given state, if there is no next state, okay, there is no next state for a given input, or from any given state, if there are more than one next state for a given input, then it is called as non-deterministic finite automata. So from Q0, it is clear. A means you should go to Q3, B means you should go to Q1. From Q1, if it is A, where to go, it is not mentioned. If it is B, there are two possibilities. One within Q1 itself, one is to go to Q4. From Q3 and Q4, what is the next state is not given. So something like that, if you have ambiguity or don't know what is the next possibility, that is non-deterministic finite automata. Okay. Here it is deterministic because for every state, we know based on each input, what is the next state? And there is one and only one next state. There are no more than one next state is not there. Okay. Understood this? So to write this much, you will get 3 marks. Okay. We have another question. That is, give one string that will be accepted and one string that will be rejected by this finite automata. Now you have to understand what is the meaning of this finite automata. See, initial state is Q naught. From Q naught, if I give A in the beginning, okay. One example to find domain, codomain and range. Oh, that is super simple, Shweta. Yeah, I will explain that after this. See, observe here carefully. From Q naught, if it is A, if it starts from A, then it will go to this Q3. Okay. And once it goes to Q3, whether it is A or B, it stays in Q3 itself. It doesn't reach the final state. Okay. Any string that starts with A does not reach the final state. Did everybody understand this? Next example. Let us assume it starts with B. Now, first one is B and then goes here to Q1. If second is also B, it goes to Q4. After going to Q4, whether it is A or B, it will remain there only. Okay. First one is B, second one is A, it comes to Q3, and from Q3, it will not go to next state, it will remain there only. So basically, what are the accepted strings? Any string starting with two B's. Okay. Starting with two B's, or you can write it as BB. It should start with BB. After that, it can be A or B, any number doesn't matter. From initial state, you pass B and then it goes to Q0 to Q1. Again B, from Q1 to Q4 it will go. That's it. It is an accepted string. Suppose you have BBA. First it is B, then it is B, goes to Q4, then A, see whether A or B, once it goes to Q4, whether it is A or B, it stays there only. So after this, whether you give any number of AB, it remains in Q4 only. If it is like this, first is B, it will go from Q0 to Q1. Next is A, it will come to Q3. After that, B and A is there, but once you come to Q3, whatever are the next set of strings, it stays in Q3 only. So it is not accepted. Is that clear? Suppose a string starts with A. Now, the moment it starts with A from Q0 itself, it goes to Q3 and never goes to any other state. Once it reaches Q3, it will stay there only. So it is not accepted. So what are the strings accepted? Strings starting with BB. Understood how to identify what type of strings are accepted? So to know what type of strings are accepted, start from the initial state and reach the final state. And see what all are there along that path. Q0 to Q1, Q1 to Q4. These are the things available. So B and then B. So anything, once you reach final state, any number of letters, it remains there only. So all the strings that starts with BB are accepted by this automata. Once you understand that, accepted strings. Now you write example 1 is, write anything that starts with B, 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 A, B. And then now you should show what are the transitions. So from Q0, the first string to pass is B. This takes it to, from Q0, if the input is B, it takes to Q1, write Q1. Next input is B. So from Q1, if you give B, from Q1 for B, it goes to Q4. Again, you have A, right? From Q4, if you give A, from Q4 for A, it stays in Q4 only. Then again B. So from Q4 for B, again, it stays in Q4 only, which is accepted. Therefore, BBAB is accepted by the given automata. Okay, and give any string that starts with A or BAB, something you give, BAB, something like this. And then from Q naught, first input is B, that takes it to Q1. Second input is A, that takes it to Q3. And third input is B, that remains in Q3 itself. Next input is B, that also remains in Q3. You can even take a 3-letter string. Okay. So at the end of the string, if you are in final state, then it is accepted. If you're not in final state, it is not accepted. All of you understood this? Okay, Shweta, last question. This one. Domain, codomain, and range. This also I have explained in detail. See, to find domain, codomain, and range, there is a function from A to B. Okay, A to B, there is a function mapping. I'll take A, B, C here. 1, 2, 3, 4 here. A is mapped with 2, B is mapped with 4, C is mapped with 1. Just an example. First set is a domain. Domain of this function is a first set, which is A. This is a domain. Okay. Codomain is a second set. Second set here is 1, 2, 3, 4. This is codomain. Range. Range means elements of the second set which are taking part in the function. See, in the second set, we have 1, 2, 3, 4. But all of them are not linked with the elements of the first set, right? Only 1, 2, and 4 are linked, 3 is not. So only those elements that are taking part in the function, that is called as range. So here range is 1, 2, 4. 3 is not connected to anything, therefore 3 is not part of the range. Understood this, Shweta? Domain is a first set. This is domain. This entire set is codomain. Range is elements of the second set which is taking part in the function. From first set, everything should take part in the function. Otherwise, it is not at all a function. Okay. Hina, last one, it is getting late. Box contains 3 red, 3 blue, 3 white balls. How many ways can 8 balls drawn? One at a time. Provide order is important. See, exact same question I have solved in combinations. Please go through that. Same question I have solved. Yeah. See here. Combinations under discrete max, previous year questions. Whatever you have asked, same type of question I have explained here. Please go through this. Oh, one question only you have explained for such a long one. Okay, then. I think I have, so what is the one that you have asked? Order is important, it becomes permutation. See, whenever the question is box contains this many socks, this many colored balls, it is always combination. Whether they give order is not important, where E is important, they won't give. They won't give that order is important or not important. That won't be given. See here. This is an example combinations video. I have explained something similar to this. Please go through that. Okay. I've also explained variations of this question. Where is that question? Order is important, right? If it is order important, then it is dependent function. This question, no? Nina? Box contains 3 red, 3 blue, 4 white balls. In how many ways can 8 balls be drawn out of the box one at a time, provided order is important? So you should take out 8 balls, and here whether order is important or not doesn't matter. They have not given any particular category here. They have not mentioned they need this many red balls or this many white balls. They have not given that they should be of the same color or different color. Nothing is given. So it is very simple. There are 3 red, 3 blue, and 4 white balls. Okay. Given number of red balls 3. So write a full sentence. Number of red balls 3. Number of blue balls is 3. Number of white balls is 4. So total number of balls is 3, 3 and 4, 10. Okay, there are 10 balls. And in how many ways can 8 balls be drawn one at a time, provided order is important? Okay, since order is important, I think you have to take it as permutation, but it is a tricky question. Usually this type of question is all combination. They have given order is important. Therefore, it is a permutation question. How many you have to take out? 8. So number of ways of picking 8 balls from 10. Okay, in a specific order. Okay, because they have mentioned order. The specific order is 10p8. That's all. Simplify this. You have to write 8 numbers from 10 in the decreasing order. That's it. That will be the answer. You can multiply and see what it is. But whenever this n is more than 8, you can keep it as it is. You don't have to multiply. See, 10p8 means you should write 8 numbers from 10 in the decreasing order, which is except the last 2 numbers, that is 2 and 1. Except that, you should write everything up to 3. Okay, so you can decide whether to write it. It's a very, very big number because 8 factorial is 4320. So half of that is 2160. So answer for this will be 2160 into 90, a very big number. So if you want, you can multiply and write. Otherwise, you can keep it as it is, 10p8 itself. Fine. Adesh Shukla. Yes, good evening. Okay, hope all these are clear. Go through all these topics and go through previous year's question papers. If you want more questions for practicing, refer to MCS 13 and MCS 33 question paper. If you are in the WhatsApp group, immediately after this lesson class, I will share the question papers. I have already shared it before. I will share it once more for your reference. If you are not in the WhatsApp group, there is a link in the video description. You can click on that and mention that you are, MCA or BCA student of IGNOU. I will share you the WhatsApp group link. Okay. So I will share this 3 question, MCS 13, MCS 33 and MCS 212. All these 3 question papers I will share. So first practice from your previous year questions and then refer MCS 13 and MCS 212 also. Okay. All the best to all of you. You can actually easily score above 40 for 100. See, getting above 75, 80, you need lot of preparation and you should have started from quite time before. But even at this stage, if you practice, you can definitely pass. Passing marks you can get. Refer to these videos, refer to mathematical induction is also there for you. And then discrete maths. graph. There is one video on graph. So all this, if you refer, you will definitely be able to attend for more than 50 marks. Okay, all the best. See you all. Bye bye.